Hello, bonjour, and welcome to the Don't Wastewater podcast. I'm your host, Antoine Walter, and in today's episode, I'm excited to welcome Manaf Farhan as my guest. Manaf is the CEO and co-founder of EMG International, a leading company in anaerobic wastewater treatments with a pretty unique take at anaerobic digestion, as you'll notice in a minute. In this week's episode, we'll question if the good old brown water jacuzzis are really the most efficient way to deal with high-strength wastewaters, and Manaf will tell us how anaerobic fluidized bed digesters enable to produce 4 times more energy than they consume to treat wastewater, and how they can be fully automated to let industrial players focus on their production lines. He'll give us 4 good reasons to learn a new wastewater acronym with the AFBD's benefits, and share some stories to recall how Handson was literal when he started EMG together with his brother in the 90s. In our conversation, we also tackle sustainability, simple comparisons with MBBRs and microbial fuel cells, best ways to valorize biogas, how to best handle go-to-market routes, or how anaerobic digestion is actually a replica of what happens in our body. But right before we start, I need you. We're approaching the end of this podcast season 2, and it's been a fantastic ride with a combined 160,000 views so far. Yet, I'd like season 3 to be even more helpful, interesting, and interactive. And this starts with you. You'll find a link to a short survey in the show notes. Trust me, it would help me tremendously if you took just a couple of minutes to fill it out. To thank you for your answers, you'll also have a chance to participate in a draw, and 3 of you will receive a nice little personalized present from me. Just check out the link, everything is explained there. Please do it, and I'll meet you on the other side.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi Manaf, welcome to the show.
Hi Antoine, thank you for having me.
Actually, it's interesting because we are in Pennsylvania with you today, and I like to start, like usually with a postcard. What can you tell me about the place you're at right now? Something crispy, something really strange? I don't know. You tell me.
Well, I'm sitting in Media, Pennsylvania today, which is right outside of Philadelphia. Philadelphia is between Washington and DC. We're having a cool spring, so it's a little bit of a late bloom for the trees and the flowers. But there are some flowers out there, and it's really pretty. It's a nice, crisp spring day, and it's a great day to talk about wastewater.
Well, actually, when preparing for that discussion we will have together, and as I shortly alluded to you when we were just chatting before hitting the record button, when I was scrolling your website, I stumbled upon a video which is not your everyday video you see on a water industry company, and it was an interview led by a Pennsylvania state senator, an interview of you. So sometimes you see the contrary, a water professional interviewing a politician and asking him some crispy stuff about what he thinks of the environment or whatever. And here it's the opposite. You got interviewed by Senator or former Senator Pat Vance. So what's the story about that? Is there a funny anecdote about that one?
Yeah, that was an interesting project. That was one of the earlier projects we did in the early 2000s. It was at a dairy farm to treat cow manure. And that project was funded by the state of Pennsylvania. And the senator at the time, Senator Pat Vance, was interested in sustainability and promoting that kind of project and that kind of work. And so she asked if we could do an interview. And it turned out to be pretty interesting.
So that was on a dairy farm, and it touched your field of expertise, which is anaerobic digestion. And if I want to be provocative, I have to start with that one. How do you get interested in anaerobic digestion?
Yeah, it's interesting, the story of life, right? How things happen. So I studied civil engineering in undergraduate at Notre Dame or Notre Dame University, not your Notre Dame. And then from there, I studied civil engineering again, and I studied environmental engineering. I turned from civil to environmental for graduate school. So I was interested in water and wastewater treatment and sustainability for a while, a long time. This is since graduate school. And my dissertation was in anaerobic digestion. So that's how it started for me.
So you did your dissertation on that. So your PhD, right?
Correct, yes, at the University of Pennsylvania.
And since then, it was a continuous love with that field.
Yeah, yeah. Well, I did an in-depth dive into the process and the science of anaerobic digestion, and I studied different reactors and how they perform. I studied them for a year and a half, detailed analysis of performance of different digesters, and was able to compare and contrast different technologies. And after that, I just started EMG in 1996 with my brother. And we have been, ever since, we've been promoting this technology and building these systems.
So EMG is your company today that you're the CEO, right? So you're the founder and CEO. And for 25 years, you dedicate to that anaerobic digestion and a bit more, I guess.
Yeah.
Actually, I was sold to that interview by your colleague, Paul Jarrett, because he told me that you just took anything that was existing within anaerobic digestion, everything which was wrong with it, and you made it better. Sounds good, but I'd like to start with that. Actually, what was wrong with anaerobic digestion? You mentioned that you were studying that in depth. So what was it that needed to be corrected within that field?
Sure. First, my friend who introduced us is Jarrett Paul.
Oh, sorry.
So that's not a problem. So yeah, initially in the 70s, 80s, and even 90s, anaerobic digestion was primarily used in wastewater treatment plants that are municipal to treat municipal wastewater, which is typically treated aerobically with the presence of oxygen. And when that's done, it produces sludge. Aerobic systems are energy consumers and they produce a lot of bacteria or sludge. The yield ratio for aerobic systems is 0.6, meaning for every 100 pounds of biochemical oxygen demand, 60 pounds of sludge or biomass is produced. So historically, anaerobic digestion has been used in the United States, at least, to treat the sludge or the biomass that's produced from municipal wastewater treatment plants. Mm-hmm. They take that sludge and they treat it anaerobically and they produce biogas. So it's a secondary treatment or it's an afterthought.
So you have the water line in the wastewater treatment plants, and the water line is usually the one everybody focuses on. And anaerobic digestion is on the sludge line. So you extract your sludge from your aerated basins, and that you drive it to the digester, and hopefully it produces some methane. But what you're saying is that there was a better use to make from the technology and probably a better yield?
Correct. So we focus on using anaerobic digestion for treating industrial wastewater. And the easy target, the primary target for us is food and beverage manufacturing. Because obviously food and beverage manufacturing is high strength, it is biodegradable. I see behind you there's a sign for a cola product. So, when they produce soda, for example, they use sugar and they use flavorings, and the sugar is highly biodegradable. And we just put that through an anaerobic digester to produce methane or biogas instead of producing more sludge to neutralize the wastewater.
So you basically erase one step. You say you don't need to go through this aerobic treatment which produces sludge. You can directly drive wastewater in, you take methane out, and a kind of already treated water at the outlet of the digester, so that the digester is no longer on the sideline. It is the main treatment.
That's a very smart way to look at it, Antoine. Basically, instead of, I had mentioned earlier that the yield for aerobic systems is 0.6. The yield for anaerobic systems or anaerobic processes is close between 0.03 to 0.06. And so it's between 10 to 20 times less meaning that you produce for every 100 pounds of BOD, you produce between 3 to 6 pounds of sludge. And so the process itself is slower. It's a net energy producer. It produces less biomass as a byproduct. And it basically converts the organics, starches, sugars, alcohols, proteins, whatever, fats into biogas, CH4 and CO2.
How does that look like on the plant? Is it those cylinders that we see in the conventional plants, or does it look differently?
Yeah. One of the questions you asked a second ago is, how is the technology better now? How is the anaerobic digestion technology better now? As I mentioned, first, in a municipal wastewater treatment plant, the digesters, the anaerobic digesters, were large, completely mixed systems. So it's a big tub that's completely mixed, and they design it for a hydraulic retention time of between 18 and 20 days, meaning that the water would stay in the reactor for an average of 18 to 20 days. Because in those big mixed systems, the hydraulic retention time is the same as the mean cell residence time, meaning the average time that a bacteria particle stays in the reactor. So they design them so that the bacteria stays in the reactor for about 18 to 20 days, because the most sensitive bacteria in the anaerobic process are the methanogens, and their doubling time is between 12 to 14 days. And so to be safe, they design them to about 20 days, 18 or 20 days. So the next step was to go from these conventional, completely mixed digesters to a better process. And that transformation happened when automation came on the scene in the late 80s, early 90s, and then it became more ubiquitous. There's more process controls now. There's remote access. There's better reactor configurations. So in the last 20 to 30 years, that's transformed the reputation and the performance of anaerobic digesters.
You mentioned the reactor configuration. If I got it right by scrolling your website, actually, it's not just a tank that you have. There's something inside the tank.
Correct. So the process that we have is called the Anaerobic Fluidized Bed Reactor, AFBR or FBD, Fluidized Bed Digester.
That's cool, because in every single podcast, I have a new combination of letters. You know, we had MABR, MBBR, MBR. Now we are at AFBR. So sorry.
Yeah, so the AFBD, the
AFBD, sorry, yeah.
Digester, the AFBD is a silo or a tank. It's a vertical tank. We flow from the bottom up. We add a biocarrier. As you know, bacteria like surfaces. And the biocarrier is a small particle like the size of sand. And we flow upward. And so the balance between the upflow and the weight of the particle, the mass of the particle given the force down, that balance causes it to be fluidized, or it swims around in a gentle Brownian motion. And then we inoculate the biocarrier with the bacteria. And the bacteria lives on the surface of these particles. And by doing that, we have a very nice hybrid model where it's a completely mixed reactor and it's an attached growth reactor. So there's a biocarrier. So typically when you have bacteria living in water, you get bacteria populations or mixed liquor volatile suspended solids. I know you like acronyms. I'll give you more. MLVSS. So the MLVSS of bacteria living in suspension is typically about between 3,000 and 5,000 milligrams per liter. The bacteria population that we get in our AFBD system is between 40,000 and 60,000 milligrams per liter. And so we have upwards of 20 times higher biomass population. And you know, more biomass is a more stable process.
So you mentioned the acronyms. How different, if it's if the biocarrier is in movement, if it's fluidized bed, how different is it from an anaerobic MBBR, so a moving bed bioreactor?
The fluidized bed technically is in the category of moving bed bioreactors. The difference primarily is in the shape and the size of the media. Typically, MBBRs use plastic balls as the media, and they flow up and then they swim around a little bit. It's not completely mixed. It's a moving bed. And on top, they put some kind of a constraint or a net to make sure that these plastic balls don't leave. So the AFBD, the fluidized bed process, is similar to an MBBR. It is a moving bed reactor. It's a fluidized bed. It's not the same because it's a different media, and our cross-sectional area is much smaller because the reactor is more vertical.
So you put raw wastewater in, so this industrial wastewater, so high strength wastewater, and at the outlet, what do you have? Is it to which level is it treated, and what do you put behind one of these AFBD?
Sure. So our process usually has equalization and the fluidized bed reactor. We use equalization to allow the wastewater to start to break down for hydrolysis, liquefaction, and the beginning of the acid generation process. And when we do that, the precursors to methane generation are the short-chain volatile organic acids and acetic acid. And primarily, it's acetic acid that drives the methane generation. So we want to get to the point where as much of the wastewater has been broken down and volatilized and even into the volatile acids and ready to go into the methane generation. Once we generate the biogas, which is a combination of CO2 and CH4, that's collected and processed, and we recover the electricity from it and waste heat. On the backside, it depends on the discharge limits. Most of our systems for wastewater treatment in the food and beverage industry go into a sewer. That depends on the industrial user permit. That's what they're called here in the United States, IU, or significant industrial user permit, where the treated wastewater has to go to a sewer, and they tell you, for example, the BOD has to be under either 300 milligrams per liter or under, say, 1,000 pounds per day. You have a limit. So it depends on where we are on that spectrum. If we can discharge to the sewer, or if the client can discharge to the sewer without polishing, we would go straight to the sewer. Or if polishing is required, we would put another polishing unit after our system. And it could be even to the point where it could be stream level discharge, where we can just discharge it to the environment under a different permit, which here in the United States is called a SPEDIES or NIPDES permit, a National Pollutant Discharge Elimination System, or a State Pollutant Discharge Elimination System.
So if I get it right, your sweet spot in terms of application is this high-strength wastewater, which you usually would find in food and beverage. What would be the top three reasons for me? Let's say, that's the beauty of that podcast. I can imagine many things. Let's say I run a plant, a soda plant. What would be your top three arguments to tell me why your technology would be the best suit for me?
Today, we're all aware of our impact on the environment as human beings, with industries. And the goal is for us to minimize the impact on the environment. So the first and biggest driver in my mind, that's why I got into this business, is to reduce the impact on the environment. And so the soda manufacturer might make delicious soda, and they might be very excited about their products, and they keep continuously creating new products that help them into the marketplace. But every time we do that, there's an impact on the environment in terms of generating more wastewater with more pollutants. And so the first thing that I would say is, these manufacturers can put an anaerobic fluidized bed digester system there and reduce their carbon footprint, reduce the amount of waste that they put into the sewer or discharge into the environment. And sustainability is a big, important part. And a lot of manufacturers are very responsible and very aware of the importance of reducing the carbon footprint and their impact on the environment. When we put a fluidized bed digester in to treat industrial wastewater, we can reduce the organic discharge to a sewer by 80, 90, 95% sometimes. If we put polishing, we can reduce it by 99%. And then we can recover biogas, which we can make into electricity and recover waste heat from that application. And so we can then reduce the amount of energy that they use, the amount of electricity they consume per unit produced, and the amount of natural gas they consume per unit produced. So in my mind, the biggest driver is to be responsible and to manufacture sustainably. The other thing is reducing cost, because a lot of times they put these pollutants to the sewer and they have to pay a surcharge fee. So if those pollutants go to a municipal wastewater treatment plant, that treats the wastewater aerobically, which is an energy intensive process. So, that is going to have a bigger impact on the environment. And so when we put the process treatment on site, it is a very small footprint because a lot of times these manufacturers are space limited. They can reduce their discharge to the sewer and they can reduce the cost that they pay with that.
You mentioned the energy. How far are you from being energy positive with your systems?
We're there. So typically, the fluidized bed digester has parasitic energy requirements of somewhere between 20 to 30%. And so the energy required to run our system is between 20 to 30% of the total energy that we produce.
Okay. So said differently, you produce 4 to 5 times more energy than what you use.
Yep. Yeah, 3 to 4 times is right about there. Yeah.
Okay. Because, wastewater treatment plants, which are net energy positive, are a target for a while in many places. But it turns out you're not even made it, but you go beyond that.
Yeah. And, the exciting thing here is that you mentioned cutting out the aerobic process and putting the anaerobic process in there so that we don't produce more sludge. Yes, we don't produce as much sludge. We also produce energy. And so it's not requiring energy for us to treat the waste. And now we're turning waste to energy. And the other thing is, of course, where populations are growing, demands are growing. And so a lot of these manufacturers have to increase their production. And when they do that, they have to make a decision. Do we generate more waste? Do we pay more money? They put these wastewater treatment systems on site. It enables them to expand because they're treating their waste before they put it into the sewer.
Many questions here. There are many things I have to unpack in what you just said. But let me stay for a second on this energy topic. How different is your technology to a microbial fuel cell?
Sure. So a microbial fuel cell it converts the chemical energy to electrical energy by the organism's reactions. They basically create that differential between the two sides of the reaction to create electron flow to generate electricity. So for us here, we use a biochemical process to convert the organic portion into another compound, which is biogas. So in an aerobic process, for example, it converts the bacteria consume the organics, the carbon-based compounds, and they produce new cell mass and CO2. In an anaerobic process, the bacteria consume the BOD and we produce mostly biogas. So we're just converting the organics from the carbon chain into CO2 and CH4, whereas in a microbial fuel cell, they just convert the chemical energy into electrical energy.
Well, it depends if it's a fuel cell or an electrolysis cell, but you're right on the principle. And what do you do with that biogas? Is it a cogeneration where you make some heat and some electricity, or is there another use? What's the most common one?
There are several uses for the biogas. In my experience and what we've been doing for 25 years, the most profitable way to use that biogas is to put it to a combined heat and power system, which is typically a reciprocating engine that burns the methane gas, produces electricity, and then we recover about 50% of the BTU value of the waste heat. And so if we start with 10 million BTUs a day, we convert roughly between 30 to 35% to electricity, and the other 50% of that 10 million BTU goes to waste heat that's recovered. And so we reduce the natural gas consumption requirements for a plant, and we reduce electricity consumption by producing our own electricity.
You mentioned the carbon footprint, and what you just explained contributes to that carbon footprint element. Another thing which I would see with the carbon footprint is that actually we always look, at CO2 because it's these carbon emissions, but methane is much worse when you look at just the greenhouse effect. Thinks about that there must be a 20 or 25 times ratio between methane and CO2. So if you're more efficient in transforming organic load into methane and making something useful out of it, instead of just discharging everything to a sewer where a part of it would be just going to the atmosphere one way or the other, do you see here also a positive impact of what you're doing, or is it really negligible?
It is very positive. I was just mentioning a second ago that One of the things that we use the methane byproduct for is to the combined heat and power, CHP units. They also can be that fuel, the biogas can be sent to a boiler on site to produce heat, or we can purify the biogas and put it into pipeline gas quality, which is, it's more expensive and it has to be a bigger scale. But to your point, when we treat the organics, you have to keep in mind that they come from sugar, for example, in the soda process. They might come from dairy in the cheese manufacturing process. So that those organics were produced in the previous calendar year. So they're very short-lived, the conversion of the production of the sugar or the organics or the milk. It's a very short cycle. And so if it were to go to a wastewater treatment plant, they would treat it aerobically, so they have to spend energy to treat it. And of course, the byproduct of aerobic digestion is more sludge and CO2. When we treat it anaerobically, we produce less sludge and we produce methane gas, which is a fuel. And so we're saving on the CO2 production if it were to be treated aerobically. We're producing a fuel that can be burned to generate electricity. And because of the short cycle, the 1 year cycle, this is considered not a net new source. This is considered a zero net emissions because of that fact. And so, yes, we would produce the fuel that actually would reduce the carbon footprint and would reduce their waste discharge offsite.
There's another element in what you said before, which is intriguing to me. If I'm still that industrial owning that plant, to me so far, wastewater was more waste than water, and was something which is kind of annoying with my process because I have that as a byproduct and I have to pay for it and everything. And now what you're saying basically is that this is a resource. It is energy for my plant. It is stuff I can extract. So would you say that for an industrial, it changes a bit the way they're looking at their wastewater, because it's not just one line on the bill they have from the utility. It's also something where they can say, hey, the heat of my plant or the electricity from my plant comes from that actual byproduct from my process.
Absolutely. I think you're right on there. In the past, industries have looked at wastewater as a tax or as a liability. They look at it as something that they have to pay money for to produce, to be in business, where with our solution, with our technology, you can actually now convert that liability into an asset. And that's part of the reason why we look at industrial wastewater, because it has high concentrations of BOD. It's effectively sugar water, or it has, milk waste, and it has other byproducts in it that are organic based. It's food waste that we're going to convert into energy. We have basically converted a liability or a problem into an asset. The issue that we fight the most is acceptance, because people still don't trust wastewater treatment. They still don't trust that it can be done effectively and reliably. And they think, I'll just put it in the sewer and pay that money and not have the headache. And that's where our process comes in. And we've actually changed a lot of people's outlook on this, because it's reliable, it's automated, small footprint, and it makes their life easier. And they can then say that they're producing more, but they're reducing their carbon footprint as they're doing it. So they're producing sustainably.
I've seen on your websites that you mentioned as an asset from your AFBD that it recovers pretty fast and pretty easily from upsets. But what upsets your system? What can happen on the stream that upsets your bacteria, I guess?
I would say, there's several things that can happen in an industrial process, and most of them are human error. Obviously, no one is perfect. And so this is where we try to automate as much as possible. When you look at a plant making cake or soda or packaging milk, they might have a batch that's out of spec, that sat in the tank for too long, or someone added too much sugar, or something happened and it's just off spec and they need to get rid of it. Well, they have to get rid of it because they have to get the next batch in and produce and bottle. So the only way to get rid of it is to put it down the drain. Some manufacturers have the ability to segregate that high strength waste and put it into a tank and ship it off and make it someone else's problem. But when a system is designed to handle, say, 5,000 pounds of BOD per day, biochemical oxygen demand, and all of a sudden you give it a waste batch that is off spec that puts in 12,000 pounds that day, you've more than doubled the load. For a typical biological system, that can create upset. For the fluidized bed process, it can handle it. And that's part of the reason why we chose to build these fluidized bed reactors, because they have a very high tolerance for shock loading, for chemicals that are used for cleaning and biocides and disinfecting, because of the high biomass population. I mentioned to you earlier that we get a biomass population of in the order of 40 to 60,000 milligrams per liter. And so there's a lot more biomass, and they can take that hit.
It's funny because what you explained me here reminds me of a story which I've heard. I don't know if I'm allowed to tell that story because I heard it off microphone from one of my previous guests, but she was explaining me that she was working on a brewery, and they had high organic loads entering the wastewater treatment plants, and no one understood where that was coming from. And after days of investigation, they found out that someone was just washing off some tanks after the production of a special beer, which was, a sugar beer, one of these party beers. Let's put it that way. And
that's unspeakable.
and when they were washing that off, it looks like water. I mean, it was water with sugar, but for the operators, it was not possible to imagine that was a waste and that was a real problem, because, I mean, sugar in water is fully transparent. You don't see it. For them, it was just a perfect stream. So they couldn't imagine that would be the problem. So when you mentioned this element of automation being a key, I could imagine that you need to avoid trouble that would happen just because the operator is an absolute expert when it comes to his process, but just has little clue when it comes to water and wastewater. So what does automation change here? What are you able to automate?
That's a great point that you're asking, because the people who do the production, they know how to make soda, they know how to make cheese, they know how to make cake. They don't care about wastewater. To them, it's an afterthought. And yeah, water with a lot of sugar, beer water with a lot of sugar in it, it's no problem. The guy can probably drink it and put the rest of it down the drain. We have a client that put some ice cream in the trash. And I looked at that ice cream and thinking, this is delicious stuff. Why are you wasting it? But of course, they have their standards, and they have, whatever fits within their packaging requirements, that's what's going to go. So the anaerobic process is sensitive in only that the methanogenesis, which is the step that produces the methane gas, is sensitive. That's the bacteria of the 5 or 6 different groups of bacteria in the anaerobic digestion process that is the most sensitive. And they require pH, they require temperature, they require loading rate, they require nutrients. So they have these strict requirements for environment that will make them thrive. But if we're able to maintain these conditions, they will thrive, they will be reliable, and they will produce methane gas, and they will treat the wastewater. And so, you can take a world-class athlete and you feed them junk food, and you don't give them enough rest or training, and they're just not going to perform. So it's the same concept here. So we automate pH with duplication. We automate the wastewater flow rate. We automate the temperature control. We measure, for example, the biogas generation rates. We also measure liquid levels in equalization tanks, in the chemical feed totes. We keep these things on a strict diet and under strict environmental conditions. When we do that, that's how we optimize the performance.
You keep them under a strict diet, but you're not monitoring the organic loads. How is that possible?
We are monitoring the organic loads. You can monitor the BOD of the wastewater coming in or the COD of the wastewater coming in. It's expensive. An inline COD meter is about $100,000 US.
And spectroscopic sensors or...
Sure.
Okay.
Yeah, they're not as expensive. You can do like these photo cells that can do it, cheaper based on solids. But the solid cells are only are good for waste with high solids. They're not good for waste with dissolved organics, like sugar production, for example. So there is technology out there that you can monitor the strength of the wastewater coming in. But here's the thing. Understanding the anaerobic process itself, and with the high flow rate that we have in our reactors respond within 15 minutes of introducing higher strength wastewater. So if you give them, let's say they're used to getting wastewater with a BOD of 3,000 milligrams per liter at, let's say, 50 gallons per minute. You keep the 50 gallons per minute, and then you give them 10,000 milligrams per liter. Within 15 minutes, you'll see a spike in the biogas generation. 15 minutes, you'll see a higher biogas generation rate, higher pressure, at higher biogas generation. And so we have the ability to modulate the performance of the reactors and the operation of these reactors based on the biogas generation, because it's a very short reaction time.
You get this sign which tells you that organic load is just going through the roof. What do you do with this information? Do you cycle it back to the operator and saying, hey, that doesn't sound like something that should happen, so maybe you shall have a look at your process. Maybe there's something which is open which should not. Or are you just use an equalization tank and wait for it to be a bit easier to treat or in the right window?
So we do use equalization, and typically it's about a half a day of the flow of the plant. So it's pretty small size. Once you have more biogas generation, it means that there's more organics going through the process. And of course, it's a step process. And so the funny thing is that at that point, when your biogas doubles, for example, you're going to have other indicators, like the acid generation is going to increase and the methane generation will try to catch up to it. And so when that happens, your consumption for chemicals to control the pH, for example, 50% caustic, will increase. And so as long as the system is equipped to handle it, as long as we have enough caustic to control the pH of the reactor in the level that we need it, and we're producing biogas, it will recover no problem. If we run the reactor at a higher organic loading rate, and it happens that the plant has run out of caustic at that instance, if at that moment there is no caustic to control the pH of the reactor, then the pH will start to drop. That's when we alert the operator. That's when we say, you have a problem, you need to stop. Either look at the strength of your wastewater coming in or make sure that there's enough caustic to keep the reaction in balance.
I'd like to come back to operation in just a second, but there's a last thing. You said you're monitoring temperature. Are you heating up your system as well?
Of course, yeah. So anaerobic reactions, the anaerobic digestion process is optimal at a temperature between 95 and 105 degrees Fahrenheit. So in French, that would be about 35 and a half to maybe about 38 degrees, maybe 40 even.
Thanks for the translation.
Hey, no problem. I'm going to need you to translate cubic meters to gallons later, so we're good. But so we do the anaerobic digestion. It's the same bacteria we have in our intestines. And so they're used to 35.5 degrees C, 95 degrees F. And so if the temperature drops, they're going to have a stomachache. If the temperature drops, they're not going to be able to produce. As a matter of fact, there's a precipitous drop in the methanogenesis activity once you go below 85 or 84 degrees Fahrenheit. And so we have to bring it up to the optimal temperatures between 95 and about 105. Even 110 for those bacteria to produce optimally.
We've discussed a lot of technical stuff since the beginning of this conversation, which is fascinating to me. But I would have also a couple of business questions. You mentioned operation, and I was wondering if the system is so much automated. I mean, if there's so much that you can actually automate, is it also within your reach to operate it instead of the operator, to do like remote monitoring or even remote operation?
Of course, absolutely. So we design a programmable logic controller, or a PLC panel, that reads the temperature and the pH and the flow rates and liquid levels and the pressures from 20 or 30 IO cards. And we take that into a SCADA screen, a supervisory control and data acquisition, that basically automates the performance of these criteria within certain ranges. And you can actually remote access that. You can access that from where you are in France right now. I could give you a login to some of our systems in the United States, and you can change some of the parameters. We could do it worldwide with the internet, which is the great thing about new technology. We're using it to our advantage. So we have several systems that we operate remotely, and we can change the parameters based on what we see, because we log on remotely from our office and we see several systems, and we can change wastewater flow, we can change temperature, we can change pH control with caustic addition. So all these things we're able to do remotely, which makes the system performance that much more reliable.
The reason why I'm curious about that is that because, again, when I was preparing for this discussion, on your website, I saw that you have some options for financing. So basically zero money down for still me as a customer, so an industrial player. And I was wondering, that's still leasing or rental or financing, but would it be possible to go to the next level and to say you put something on premise for the industrial player, but you would actually fully operate it remotely and you would sell a treatment capability, or why not sell energy? Is it something which is doable, or is it science fiction?
No, it's very doable. So yes, we do lease and rent these units to clients so that, of course, there's a lot of financial stresses on them because they want to make sure that they're profitable. And so we lease them or we rent them to make the cost on their balance sheets more on operations rather than on a capital expense.
Yeah, you turn a capex into an opex. And that's, to me, as an industrial, it's
exactly. They love it. Yeah, it's great. Yeah. But the other thing is we also offer service plans where we provide long range, remote tech support. We can provide more on-site, on a periodic basis, or we can run the system entirely. And the benefit of having our systems so highly automated is that the required manpower to do this is very little. So we have systems that can handle upwards of 20,000 pounds of BOD per day, 5 digester units, and they need 2 hours a day of operator time because they're almost fully automated. So we also offer the option to install these systems, finance them, and operate them for our clients.
You're called EMG International. How international are you?
A lot of people ask me that question. First of all, personally, I'm from Jordan. So I came to the United States to go to college. So in itself, that is somewhere, crossing international borders.
It's already very international.
Yeah. But we also have partners in Canada with TransAlta is a large utility in Calgary in Alberta. And they're equity owners, they're our partners, and they believe in our mission and they support us with what we're doing with treating wastewater sustainably.
So it's really a North American focus, if I might say so.
Yes, it is. For now, it is. TransAlta has offices in Australia. We have consultants in England, in London, which used to be part of the EU. Unfortunately, you people threw them out or they jumped off the cliff, whichever you want to call it. So we are interested in the European market and the South American market as well.
What's the sweet spot for your technology? Because we said it's high strength wastewater, but where does that start and where does that end? I mean, maybe that doesn't end. Is there an upper limit and a lower limit where you would say you're the best suited technology?
Yeah. So our technology is, a lot of times it's driven by cost to the client because of what they spend on their wastewater. If a client ships their wastewater off-site because they're not allowed to put it in the sewer because it's above a certain threshold, then it becomes a lot more financially feasible because shipping costs are higher. If our clients' costs are driven by compliance or by, they're putting too much to the sewer and they have surcharge there, then it's a different conversation. So for us, if we're talking about just the technical application, anything between, I would say, 2,000 pounds of BOD. Do you use BOD in France? Is that an indicator?
Yeah.
Okay, great. So anything between 2,000 pounds, I ask you now, 45 minutes in, right? Anything between 2,000 pounds of BOD on up to even 100,000 pounds of BOD we can handle. It is modular, so every unit would handle a certain amount of BOD per day. A high strength waste becomes our specialty because a lot of biological wastewater systems shy away from very strong wastewater. For example, whey, which comes from cheese manufacturing or yogurt manufacturing, is very high strength. It can have a COD of 100,000 milligrams per liter. And that's very difficult for aerobic systems to handle. And if you're putting it through other digester systems, you have to watch the flow rates, etc. That becomes where we excel. We also excel in areas where footprint is very limited because we have the highest allowable organic loading rate in the industry because we have the highest biomass population in the reactors. And so we require the smallest footprint.
You mentioned that you founded it actually. It's not you were founded, so you founded it in 1996. So that makes 25 years of history, which is already much of a milestone. How big are you today? How many people are working for EMG?
We're a pretty small company. We are a very dynamic team. We're between us and TransAlta, obviously, it's a different count. Right now, we have the ability to expand very quickly by bringing in people from the TransAlta team because they give us a lot of engineers and a lot of resources. And so to answer your question, it depends on how you count it.
No, I wasn't asking to push you in a corner. It's because, one of my latest guests, Gaëtan Suzner, on that microphone, expressed that in the water industry, there's a very strong network of smaller startups or smaller size companies and not so much scale-ups. And we were discussing if the scale-ups weren't existing because it's really technical industry has its niche and specialized applications, or is as soon as you become big enough, you're a good prey for a even bigger player to just do kind of external innovation by buying you in. So I was just trying to put you on the map just in order to shape my next question, which is where do you see yourself in 5 years?
Yes, we got to the point where we were a startup 25 years ago, and the first few systems that we built was difficult to get people interested. But once you have the first one in and you prove the results, you get the next one easier. And you have two, and then the third one would be easier. We got to the point where we got the attention of the folks with TransAlta. They have a very strong focus on sustainability and renewable energy. And so last year, they acquired a part of our business. And so now it makes us a much deeper, bigger team. In 5 years, our goal is to have the fluidized bed as the leading anaerobic digester technology in the United States and in Canada. The market is huge. We have a lot of applications and a lot of opportunity for us to do that. And the market is growing. And so we see really unlimited potential, and we can do a lot of help. We can do a lot of good things for our clients in this industry.
Actually, I sent you to the future, but you just alluded to something in the past, which I'm very interested in. Can you remember the story of your first project? How do you come to, do you remember the plant it was? It's something you can still talk about. How do you come with a new technology and push it to the market?
Of course, that's a great question, Antoine. The first project that we did was in 2003, 2004, and no one would listen to anybody saying, hey, I have a great technology, this is going to be the best next best thing, and you have no proof. You haven't built any other systems. So we built it at a cheese plant, and the arrangement was that we would build it on our cost, and once it performs, they would buy it from us. And so we borrowed as much money as we could to be able to afford the equipment. It's very expensive for us at the time. We're a very small company. And by some miracle, we put a very first system in place. We put that tank in place. And my brother and I, he's my partner, we built that first system with our hands. We're both engineers.
Wow.
We used some help from local plumbers and local electricians, but we did the majority of the work ourselves. We were trying to cut costs and make sure it works. And I'll tell you one thing, that first system that we put online in 2004 is still working today.
So basically the question I was asking you, if you're going to market it as a service, that was what you were doing from day one. Actually, your first plant was a plant as a service.
Yeah, we had to do that because, it's hard to sell expensive solutions, multi-million-dollar solutions, if you don't have the track record. But we believed in the technology, and I saw firsthand what this technology can do. And that system that we built in 2004 is one of our best systems. It's still operating, and we take people there and we show them. It's like our history. We show them that digester. I wish I could show you a couple of pictures maybe at another time. But it's, that initial setup was a service that we would put it in place, treat your wastewater, reduce your surcharge fees, get you in compliance, and that's how we both benefit. And that worked out well.
And when is the last time that you've been directly involved hands-on on the building of a plant?
So it's been a while. Our company now is broken into divisions, and the operations division, which is headed by my brother Yassar, he designs these systems and he has a team and they execute and they build them. Him and I still interact on the design and some of the details of the 10,000 foot level for the design and the sizing and the layout, etc. And he takes the lead on the execution. And I do other things for the business. But personally, I haven't done one of these in several years. I do miss it. But when I go to see them, it's exciting because it's like, seeing something that you've created so many years later. It's just, being done on a much bigger scale now. It's really exciting.
Well, Manaf, we've made a good tour on that topic. I would have, further questions, but at some point I have to be a bit cautious of your time as well. I propose you to switch to the rapid fire questions.
Uh-oh.
It's time for the rapid fire questions.
Don't worry. In this last section, I try to keep the questions short, and ideally, you would keep the answers short as well. But don't worry, it's always me who is going to make it much longer than I should. So if there's anything you want to explain me a bit more, don't limit yourself. So my first question is, what is the most exciting project you've been working on and why?
That's a good question. So one comes to mind immediately. We're working on a bean plant. It's a very large plant, over 1 million square feet under roof, and they have several different products. It's the highest flow that we've handled, designed for upwards of 750,000 gallons per day, which is a lot of flow going to these digesters. We've dealt with a lot of challenges in terms of getting the wastewater there and getting it to how we need it to go into the digesters and the layout and planning for expansion. And one of the best reasons I like working with that client and on that project is that they're so excited about what we do and the technology and what we can do for them. It really feels that we're a team. Those are the ones I enjoy the most. And those guys are just they're nice people to work with, and they're genuinely excited about what we can do to help them reduce their carbon footprint. And that's why I really love that project.
Are you allowed to say where that project is?
Sure. It's in Faribault, Minnesota. It's Faribault Foods in Minnesota, which is about 1 hour 45 minutes south of the Twin Cities, Minneapolis and St. Paul. Now, I might ask you as a Frenchman to tell me how to pronounce Faribault, if you can look it up.
I'll check that. What's your favorite part of your current job?
I would say creating and designing better solutions and reliable systems, especially when we're told it can't be done. When someone tells you, no way, it's not going to fit, or it's just not going to work. And when we do this and we make it work and they come to us to say thank you, that's very gratifying.
Do you still get people telling you it's not going to work even after 25 years?
Everywhere. There's people out there that tell you that we haven't landed on the moon.
True.
So, yeah, you get this. It's changing the mentality. The wastewater industry is very old. It takes time to change, and people have to see it to believe it. There are people who are believers in the science and in technology and in when they see data, and there are people who are just skeptical by nature, and you just have to prove that it works.
Well, you mentioned it's an old industry, so the next question is going to look at the future of the industry. What is the trend to watch out in the water industry?
I believe sustainability is a big trend. in the water industry. Reducing the carbon footprint, treating sustainably, reducing water consumption. And the other thing is automation. I think those two are, in the next 10, 20 years, are going to be at the forefront of innovation in the water industry.
Actually, I warned you, I'm always the one to sidetrack. But now that you mentioned automation, I was wondering when you were explaining how much of a resistance do you still have to overcome when you tell to industrials that you can have remote access? I mean, you gave the example that you could give me access from France to the plants you have in the States. Is it something where people are still worried about, or they get that it's going to be safe anyways?
So a picture is worth 1,000 words. We have that saying in English. I don't know if you say it in French. But the best thing is when we're at a meeting with a client and I mention automation, on my laptop, I log on to one of our systems and I show them how it's working. I show them the flows and the pH control and the temperature and the biogas generation and the electricity being generated every second. And once they see it, you see the transformation in their eyes. Like, wow, this thing is real and it works. And we do the design for the SCADA screens so that it reflects reality. So the operator can actually trace what they're seeing on the screen with what's happening on the ground. And it's really neat. And I think that part of it, the great thing about having these tangible systems, these big, actual systems that are on the ground that work, is that you can touch them and you can feel them and you can see them. And so that part of it, it's easier now to produce. Once you have these systems working, it's easier to convince people that these things work. Well, at the beginning, 25 years ago, that was a bigger challenge. That was just a vision that we're seeing that what we could do. And thankfully, we were able to do it.
Well, you're bringing transparency somehow. So you're breaking down kind of a barrier for people. Wastewater is something they couldn't grab, seeing things on a screen which tell them it's good or it's not good. I think it's something which is, and no pun intended, but it's digestible a bit better for them.
I was wondering when you're going to do that. Excellent reference. I like it.
What is the thing you care about the most when you're working on a new project? And what is the one you care the least?
The most important thing for me and for our team on these projects is to be prepared. It's to understand the depth of the problem or the situation and understand their limitations, understand their permit limits, understand how they operate. So for us, the more information we have, the better, because when we know something, we can prepare for it. So for me, obviously, it's important that you have buy-in from the client and that they're committed, but we need to know what's happening at their plant and their limitations so we can custom design the solution that works best for them. The thing I like the least, obviously dealing with large corporations, there is a lot of politics and personalities. And a lot of times the politics part, I don't enjoy too much.
Okay, I don't know if I'm allowed to say it because you don't name it on your website, but you have a picture, but it's an energy drink, not the one that gives you wings, the other one. And is it difficult to deal with such a huge customer as opposed as, I guess, a dairy farm?
So here's the thing. Everything has pluses and negatives. So when you deal with these bigger corporations and they have teams and they have, budgets and they have schedules that you have to fit, these things are good because they define your mission and what you have to do and your goals. But they could be a maze, when you talk about their EHS or when you talk about their all these departments that come and give you their review and what you have to follow. So it could get complicated. We haven't done dairy farm projects in over 10 years. We've transitioned now more to industrial wastewater treatment, food and beverage, because of the need is much bigger there. But, I have to say at the end, Antoine, people are people. And I enjoy working with people and finding out what their problem is and helping find solutions.
That's a positive way to summarize it. Do you have sources to recommend to keep up with the water and wastewater market trends?
Sure. Yeah, I often go to conferences and I take part in sustainability forums. I mean, if I have to give you one, there's a lot of good things, but maybe, the Water Environment Association, they have them in every state here in the United States. They have these seminars and that I've participated in, they're helpful. And obviously reading blogs and websites that have updates is helpful. What do you use?
Well, I was going to tell, it's refreshing because you're not giving me the one that everyone gives usually, which is LinkedIn. I'm using LinkedIn a lot, but sometimes, and not sometimes, I think it's good to be a bit outside of a kind of formatted environment and to go a bit aside from what the algorithm tells you is interesting to you. So,
yeah, we use LinkedIn a lot. Don't get me wrong. We use LinkedIn and we're on LinkedIn. But there's a lot.
It's refreshing to hear that it's not your primary source because don't get me wrong. I mean, I love LinkedIn. It's an awesome source of many stuff but sometimes the algorithm has the shape of things he loves a bit better than others, and so a very interesting topic can be buried just because it's not in the right shape, and something which is arguably not of upper importance just gets pushed a lot just because it's in the exact right shape. Not doing any kind of LinkedIn shaming. I would be the wrong person to tell that. But yeah. Last question on my end. Would you have someone to recommend me that I should definitely invite to be your follow-up on that microphone?
Let me give that some thought. And I have your email address, and let me ask if a few people that I have in mind would be interested. Your focus is obviously on wastewater, so I'll keep that in mind.
Well, my focus is on every cool story which is around that. So it can be wastewater, but it can be really. I had fun discussions which had little to do with the wastewater, but had to do with water as a broader topic. But to anyone listening to that, just I'd like to thank Jarrett Paul, which I'm mentioned as Paul Jarrett. I'm sorry for that. So Jarrett, thanks a lot.
Because, right.
He was the one making the introduction and making for that cool discussion we just had. So
yeah. Well, thank you very much for your time, Antoine. I appreciate it, and I appreciate your interest.
Well, thanks a lot, Manaf, and talk to you soon, maybe in 5 years, to check if and how you became that leading technology for food and beverage, wastewaters, and beyond.
That sounds great. Merci beaucoup.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.